Okay, so today is lesson 26, data representation. So data representation is really just identifying components from a graph and finding certain percentages or certain numbers. So first problem is Travis asked students in his school to name their favorite sport. He displayed his results in the graph below. Which two sports did the same number of students choose? What is the total percent of students that chose those two sports? Well, before we actually answer that question, we're going to figure out, we're going to answer some different questions to lead up to that question. So the first question we're going to answer is, which sport is the most popular and what is the least? Well, the most popular sport is going to be basketball because it's the tallest bar. And then the least one's going to be gymnastics because it's the smallest. So the answer is most is basketball and the least is gymnastics. Another way you could have done it is basketball has the biggest percent and gymnastics has the smallest percent. Okay. How can you tell which sport is the same number of students that chose their favorite? So the way that you can tell is the bars are the same height on the bar graph, and also they have the same percents on the circle graph. So which sports were chosen by the same number of students? So the sports that were chosen by the same number of students was basketball/softball and volleyball. The reason why they were chosen by the same number is because they have the same percentage, 19%, and they also have the same type of bar. So now we can figure out their total percentage of students who chose these two responses. So you're going to do, well, basketball and softball have 19 and volleyball has 19. So you're going to do 19 plus 19, which is 38%. Okay, well, let's find out more. Different graphs can be used to show the same data. Each graph has a different purpose. So determining the purpose for graphing a data set can help you choose the best one to use. A bar graph can help you compare different parts of the data set. Each bar represents one part of the data set. So comparing the heights of two bars allows you to make a part-to-part comparison. In the bar graph on the previous page, you can compare the number of students who chose gymnastics with the number who chose volleyball with a ratio of 22 to 38. A circle graph can help you compare a part of a data set with the whole. The size of each piece of the graph shows how a particular category relates to the whole. Circle graphs show the percentage represented by each piece. You can use a proportional relationship to find the total number of students who chose basketball. So the percentage who chose basketball over 100% is equal to the students who chose basketball over the total number of students. So the way you just cross multiply and divide. All right, well, let's think about it a little bit more. So describe a situation where it would be easier to use a bar graph to compare data, and describe another situation where it would be easier to use a circle graph to compare data. Well, this is what I said, and you can say something different. I said a bar graph shows the exact number of customers who bought certain types of refreshments at a ball game, while a circle graph shows the percentage of each food item sold. Okay? Okay. So let's read a little bit more bar graphs. So the bar graph shows the number of customers that visit a clothing store during 1 week's time. What percentage of customers visit on the weekend? Okay, well, let's figure out some information before we can answer that. So the first information we need to figure out is how many customers visit the store during the week. Well, during the week would be Monday, Tuesday, Wednesday, Thursday, and Friday. So Monday has 50, Tuesday is 40, Wednesday is 50 again, Thursday is 55 actually, and then Friday would be about 90. Okay, so I added up here, and when you add them all up, you should get about 360 customers. Okay, so now we got to figure out how many customers went on the weekend. On the weekend, I would say about 130 or maybe 125. And then Saturday, or 125, and then Saturday would be about 150 or 155, which I add together, and you get 260 customers. So now we need to write a ratio, which I actually already showed you. Write a ratio comparing the number of weekend customers to the total number of customers in 1 week. Well, so to figure out, we first have to figure out the total number. So we're going to take our week customers plus our weekend customers and then add them together. And I think I added something wrong. because you get 620, which you should not. You should have gotten 560. So I think I did something wrong. I believe that this is supposed to be 300 customers. So we're going to make that 300. That actually seems better. So 300 customers. So my total is 560. Okay, and we can always get different numbers because it's not exact on the graph, but these are a little bit rough estimates. So my total number is 560 customers, and so it wants to make a ratio comparing the numbers customers for the weekend. So I had 260 customers for the weekend, and I had 560 total customers throughout the entire week. Okay, so now we're going to find the percentage. Well, the way you find percentage is you just set a proportion x over 100. So then you cross multiply. Well, x times 560 is just 560x. And then 260 times 100 is 26,000. And then you divide. And you actually get 50. So it's about 50%. Okay, let's try your turn. So let's do another problem together. So I would recommend is pausing the video and trying it by yourself. Okay, a flying disc catch competition was held at a local dog park. The graph below, the graph shows the dog breeds entered in the contest. What percentage of the entries were spaniels? Well, I have a spaniel here and another spaniel here. So the first thing you always do is find the total amount. So here's 12, 11, 15, 10, and 12. So you add this up, and I believe, so this is 22 plus another 23. So 22 plus 23 is 45, plus another 15 is 60. That's what I was thinking. So it's 60. So there's 60 total dogs here, and we're only looking at the spaniels. So, well, there's 11 cocker and 11 springer. So you're going to add them together and you get 26. Well, then you're going to set it up x over 100. So, because it's 100%, because you want to try and find the percentage. So you get, when you cross multiply and solve this proportion, you get 43.3%. Okay. Risha used a balance to find the mass of manure samples in her lab to the nearest tenth of a gram. She recorded the masses on this dot plot. What percentage of the minerals has a mass greater than 1.5 grams? Well, before we figure that out, we first have to answer some questions. So it says, estimate the percentage of samples with a mass greater than 1.5. So let's just estimate to figure out where we are so we can, when we actually get our answer, we can actually figure out if we made a mistake. Well, so there is 1, 2, 3, 4, 5, 6. So there is 6 greater than 1.5, and that there's only 4 that's 1.5 or less than. Well, so I would say it has to be about 50% or higher. Okay, so this is actually what I said. Whoops, that's not what I meant to move. I said the percentage will be greater than 50%, but less than 75. But main idea is going to be greater than 50%. So when we actually find the percentage and it's less than 50, then we made a mistake. So how many samples have a mass greater than 1.5? Well, we already said it was 6. So we're going to write a ratio of the number of samples with a mass greater than 1.5 to the total number. Well, there are 6 samples that's greater than 1.5, and there's 4 samples that's 1.5 or less. So 6 plus 4 is 10. So I have a 6 to 10 ratio from the samples greater than 1.5 over my total. Well, to find the percentage of samples with a mass greater than 1.5, we're going to set up a proportion. So you're going to have 6 over 10 is equal to x over 100, because that's 100%. And when you cross multiply and divide, you get 60%. So how would the answer change if you included the 1.5? Well, let's go back. So if I included 1.5, that would add 2 more. So I'll have 8 total samples. So my percentage would change to 80%. So the percentage would increase to 80% because there are 8 out of 10 samples 1.5 grams or greater. Okay, so let's do another problem. So it says, for each school day, Ms. Ross recorded the number of students who bought lunch in the school cafeteria. For 1% of school days were over 105 lunches served. Well, we want over 105. So you want this much. So there were 9 out of 20 lunches over 105 served. So you're going to do x over 100. And when you solve it, you get 45%. Okay. Read the problems below, then explore different ways to use a circle graph to solve problems. Well, Joe surveyed a group of people and asked them to choose their favorite leisure time activity. Well, if 75 people were surveyed, how many chose knitting as their favorite leisure time? Well, knitting is 16%. So what we're going to do is we're going to set up a proportion. So you have x over 75 because x represents the number of people who do knitting is equal to 16 over 100. 16 over 100 represents 16% over 100%, where you then cross multiply and divide, and then it would be a total of 12 people who did knitting out of the 75. Okay, last problem. A cafeteria offers 20 different food items for lunch each day. The circle graph shows how many items are divided by food group. How many food items are proteins? Well, we're going to do it just like we did before. So you have x over 20 food groups. And we're looking at proteins. So that's 25%. So it'd be 25 over 100%. So you're going to cross multiply. And when you end up cross multiplying, you get 5. So 25 times 200 is just 500. And 100 times x is 100x. And you divide it. And you get 5. So there's 5 food groups of proteins. All right. So this is lesson 26. It's very straightforward. Again, main idea is setting up proportions. And you only have 4 problems for your homework. All right, remember, watch the video, look over your notes, turn your homework in on time. Thank you, guys.